quickly before we move on from this section, I want to talk about similar solids. So we've seen this before when two solids of the same type with equal ratios of corresponding linear measurements such as height or radii, we can see that the two solids are similar. So we've talked about this with shapes before, where when we found using dilation either through a reduction or an enlargement, we can get the shapes to become the other shape. We said that they were similar. Same thing can be said with solids. So for instance, if I have these two rectangular prisms and I go ahead and I find, is there a ratio that can either make this smaller rectangular prism into this larger one, we can map it to that one, or vice versa, the larger to the smaller, what would it be? Now when I go ahead and I see what the ratio of each of the side lengths are to this rectangular prism, I get that they all have a ratio of 3/2 or 2/3 in their scale factor. So they're in fact similar solids because it worked out for all three sides. And then now go ahead and tell me what is the volume of each of these solids. You should have gotten 60 units cubed and then 202.5 units cubed. Notice I denoted volume of the smaller with a subscript of S, and then the larger has a subscript of L. Okay, keep that in mind as we move along. So find the volume of a cube with an edge length of 2 centimeters and a cube with an edge length of 4 centimeters. Now, the first way, and here's an image just showing 2 centimeter cube, 4 centimeter cubed. You could have just gone ahead and done, well, 2 times 2 times 2 is 8, so 8 centimeters cubed, and then 4 times 4 times 4 is 64 centimeters cubed. So the volume of the 2-inch cube, the volume of the 4-inch cubed. That's one way, and of course, you can completely do that because they're very easy numbers to work with and multiply. But the second way you could have done it is you could have found the ratio between your side lengths of your cubes. So it's either 4/2, which is simplifies down to 2, or 2/4, which simplifies down to 1/2. And taken that ratio, we talked about this before with similar two-dimensional shapes when it came to area, and that if you take your ratio of the side lengths and you square it, it gives you your area ratio. While for volume, if you take your ratios and you cube them, you can get the volume ratio. So 2 to the third power is equal to 8, and then or 1/8, because remember you can always take the reciprocal and end up getting your second ratio. And in this case, I'm going to take the volume of my smaller cube and I'm going to multiply it by that ratio of 8 to get the volume of the larger cube. So 8 times 8 is 64. And that's it. So cylinder A and cylinder B are similar. Find the volume of cylinder B. So here's cylinder A. You know its radius is 3. And then cylinder B has a radius of 6. And then we're given the volume of the smaller cylinder, cylinder A, is 45 pi centimeters cubed. So what's the volume of cylinder B? So what you should have done is, looking at the radii, the ratio is either 2 or 1/2, depending on which, either you're doing an enlargement or a reduction. And in this case, we're doing the volume ratio, so I'm going to go ahead and I'm going to cube each of those ratios. So 2 to the power of 3 is just 8, and then 1/2 to the power of 3 is 1/8. So either 8 or 1/8 is going to be my volume ratio. And in this case, I'm going from the smaller to the larger, so I'm trying to enlarge my image. I'm going to use 8. So 45 pi times 8 is equal to 360 pi, which is approximately 1,131 centimeters cubed.